So the second thing that you're going to do in your lab report to create a figure and to create a table is you're going to read in two separate files. These are going to be for your own personal experiment. And I chose two of the files that were from last year's laboratory. So those were for a different range of masses than what we ran in our workshop. And this also had a different calibration file. So there's some things that are going to look a little bit different, but the mechanical part of like what are the commands in R that I would use to read in the files and do a comparison should be somewhat similar. So the first thing that we're going to do is use read.csv to pull these into data frames. And just like we do with any read command, we want to double check that they're reading incorrectly. You can see that each of the columns is given the generic V1 to V7. Those just stand for vector 1 through vector 7. And that's what R does in the absence of headers in the file. And you can see for both of these read.csv, header was set equal to false. Now we want to go through and we want to be able to simplify the data, just like with the first example plot. We want to only really care about those first two columns of information. We care about what is the mass and what is the intensity. And by mass, we mean mass over charge ratio, but the unit for that is still Daltons. And then the intensity is in millivolts. So if I keep only the first two columns, I can add a third column to the data so that I will eventually be able to put everything together into a tidy data frame. There's a lot of different ways to do this. I like the rep command. Rep just replicates a word over and over again. So I want to make a column with the word standard for as many rows as there are standard measurements. And I can do that really easily by doing comma, number of rows, standard spectra. This philosophy of having only one measurement per row and putting a column for the type of sample, that is essentially the tidy philosophy. And so when we are using ggplot, we're going to have, and when we're using a lot of the dplyr tools for data manipulation, we're going to have an easy time using those tools. We're not going to have to wrangle things or do anything complicated if we have a data frame in that format. So that's what this whole section of code is about creating that data frame that is going to be a tidy data frame and easy to put together. Before I finish making that data frame, I want to add a third type of measurement, which is where were their matches? Where were their data and peaks found in the experimental sample versus the standard sample? I can do that in a lot of different ways. I want you guys to think about when you're writing the report, if you're going to only allow exact matches, you can do that with just merge. If you want to allow rounded matches, so this is approximately, within like half a Dalton, you can do this by rounding the column that has the mass over charge ratio in Daltons. Or if you want to create your own code, and this is pretty, there's a lot of like simple mathematical relationships you could do to do this, where you have an even bigger tolerance. So you could say, oh, I want to allow matches that are within 2 Daltons or 2.5 Daltons or 3 Daltons. Probably the easiest thing to do would be do a for loop and just kind of compare each of those values. Once I look through each of these and run the merge command, I now will have a list of match spectra. And I can see of the 153 masses that were found in the smaller file, 143 of them were matches. So there's a pretty good alignment between those two files. You might not have as many that align because we didn't necessarily run the two samples with the exact same settings, and it did not have a good calibration file, so we had some like non-linear behavior in the M/Z ratio. Once I have all those matches set up, I can create one of those vectors sample that has a list of matches that are that long. And now I can put everything together into a big, tidy data frame that is long. So it has a mass, an intensity, and a sample description where all the data for the standard spectra, for the experimental, and then finally for the matches is showing up in one place. This will let me plot it as a facet grid. So you can do this in a couple different ways. You could have them all overlap, or you could set it up so that they're, just three separate graphs that are on top of each other. One thing I didn't fix on here that I would expect you to fix is the legend. So legend says sample, and this is the default behavior of ggplot. It's one of these things that's definitely a whack-a-mole problem, is it fills, because I set the color, and by color, I'm doing the color of the line, which is the right thing to do for geom call, and the labels are the fill. It's not filling the squares. It's just doing the outside line. So it's just doing the border of the square in the legend, and then leaves it this dark gray color. We can also take this data and we can use it to make a table of only the top peaks. And so what the top peaks are, you kind of want to look at your graph to figure out what this is. I did millivolt, any peaks that are greater than 200 millivolts, but you could do, you could set that based on your own data. And once you load all these libraries, you should be able to create a data frame that is that filtered data set. So I can see that's only 23 observations. If I thought the 23 was too many to put in my lab report, I can change it to 250. And now it's only 13 observations. And then I can create an output of that as a PNG file using the cable library and also the webshot library. So now if I go to files and I go to figure, I can see, okay, this is a table that I could put in my lab report. There's a lot of things that I haven't activated within the cable package that make the table look even better. One thing is you can do shading, alternating shading. That can make it easier to read. You can play around with the column headings. Like I don't think that mass underscore DA is the way that we want to show the M over Z ratio in Daltons. I think that you could reformat the column name. And the easiest way to do that would be to change what the column is called in the data frame, and then it'll update automatically into the table. So that's the way that I created all of the example figures for the lab report description. If you have any questions, we have office hours next week, so please come to office hours. I would love to talk through any of your questions, and then your lab report will be due at the end of this class, so not until August. Let me make sure that I get that right. Not until August 17th at 5 p.m. But I think a smart thing to do is to make sure that you're done with this part, with any of the R script and creating any of the figures or tables by August 10th. Good luck, and let me know if you have any questions.